Okay, hello and welcome everyone. Hope you're having a good day so far. And yeah, I just wanted to invite you to join in. And yeah, we're going to kick off kind of a onboarding webinar here to talk about how to get started using Wherobots and how to kind of use our platform to do spatial analytics. So that's really the goal today. I want this to be kind of as interactive as possible. So if you have any questions, there's a few different ways you can do that. You can always ask them in the chat here. So there's a chat feature down at the bottom. You can do that. If you want to ask a live question, you just raise your hand. There's also a button to raise hand here. So just do that. And you can just do that, and I can unmute you so you can ask a specific question. But the agenda today is really twofold. We're going to show you a little bit about how to use Wherobots, get acclimated to our kind of our platform and get started, understand some different resources that are available to you, and then open up to ask questions here specifically why you signed up for Wherobots and what you're looking to do and accomplish. So those are our goals for today. I'll introduce myself quickly and then we'll jump into the content. But while I do that, I was hoping if you are able to and willing to, kind of put a message in the chat, just kind of saying, here's why I'm here today, what you're interested in using Wherobots for and learning about. So if you can just drop that information into the chat, that would really help me so I can address, anything specific that you have during the webinar today. So if you drop that there, I'll just introduce myself. My name is Matt Forrest. I head up all of our customer sort of education here at Wherobots. And then I help kind of drive learning resources to help people get into our platform and understand what they can use it for. So that's really all the things that I do here at Wherobots, and basically get to use our platform, do a lot of different cool things, and write a bunch of code and help folks like you get started. So I'll go ahead and kick it off. I want to keep it very minimal in terms of just acclimating to what Wherobots is. So I have a few quick slides, and then we'll actually get into the platform itself. If you can also drop in if you're familiar with what we do, or if you're kind of brand new, that'd be great. But I'll go ahead here and just kind of just quickly walk through a little bit about Wherobots and what we do. Basically, we're built on top of Apache Sedona, which allows you to do spatial processing in a distributed fashion. So if you're doing spatial analytics, be it vector, raster data, even array-based climate data, you can do that. It's a widely supported library, and it's used across lots of different organizations in the world. It's grown quite a bit from some humble beginnings here, originally called GeoSpark, and going up to that, but allows you to write Python, spatial SQL, anything like that. And Wherobots provides a cloud platform around that. So it's compatible with Sedona, which is a lot of the actual functional code you'll be writing is in Sedona. There's some functional pieces that exist just in Wherobots, which we'll talk a little bit about. There's the biggest thing is speed, scale, and performance, right? The focus here is around doing things quickly and efficiently. So it is as effective to do that in the cloud and cost effective as possible. That's our goal, is to be, the most efficient and cost effective platform from that side. It's serverless and cloud native, meaning once you spin it up, you can actually access it there. There's no compute charge when you're not running. And we'll talk about how you can kind of manage your compute and things like that. And then you have out of the box functionality for raster and vector data. So really, it allows you to connect into a lot of different formats of data, things like shapefiles or GeoJSON, even databases like PostGIS, and then pull them into Iceberg and Parquet formats, which will show you a brief kind of overview of what that looks like, and that allows you to connect into a lot of different tools here. The key is that what that looks like is effectively our compute layer, the processing layer, is optimized to understand spatial data. We're the only platform that does that in the cloud. So we can understand spatial relationships and predicates. So we have these pretty large scale performance boosts compared to other systems that are doing the same type of thing. So that's kind of how you can compare those performance benchmarks across these different tools. So with that, like I said, I don't want to overdo the slides here. I did see someone in the chat. I had one question from Mukesh. You're a data engineer and want to understand how you can optimize large raster data sets and Wherobots. Is there any way to auto-optimize and compact? So yes, good question. And we'll show you specifically how you can do some of that as well. So that is a way we can do that. And we can actually do a lot of different processing there. So if you haven't signed up for Wherobots before, you can go ahead and click Try Wherobots here. There's two different ways you can do that. You can sign up, or you can create an account right on the AWS Marketplace. If you're an AWS customer, this allows you to do that and then get signed up and using things right away. So you can go ahead and do that here if you're on AWS. Once you do get signed up, you'll be launched into our Whereabouts platform. So there's a few different things I want to call out here just to get yourself, kind of familiar with the interface and things like that. The first and like most common place people start is here starting a notebook, right? You can start a notebook from scratch and build those. And there's actually a lot of example notebooks in there as well. There's different runtimes, which you'll see here. Let me just actually switch my account here. This is what it'll look like on the community side, but let me just log in, log back out into my regular account. Go in there. And this is what it will look like from the when you get logged in. So there's different run times that you can select, and then there's spatial units tied to each. If you're in a community edition, you'll only have access to the tiny, which is just 5 spatial units per hour. That's how we measure compute here, is in spatial units. And you'll see each runtime has different spatial units tied to it. There's 3 different types. There's general purpose, GPU. This is for our AI workloads primarily, and then memory optimized to pull in high memory data sets. So there's different runtimes that you can use. I recommend kind of starting with testing on either a small or something like that. And then what happens here is when you start this up, that'll kick off the compute process and start everything there. And it will run until you choose to shut it down, or it will automatically shut down after 24 hours. But I recommend as you are starting and stopping runtimes here to be diligent about turning them on and off. We work a little bit differently. We work much more like if you're familiar with like in the cloud, like an EC2 instance. If you start it up and don't stop it, it'll keep running compared to like a data warehouse, like a Snowflake, where you run a query and you build based on the query, and it will start and stop. There are services that work like that within Whereabouts, which we can point those out as well. You can also give this a name. You can set it up in whatever region you want. And then we also have a preview for our Whereabouts DB 2.0, which has it's basically a vectorized engine that will speed up everything. So you can go ahead and set that up and test that out as well. There's also environment presets. So if you need specific Python libraries in here, like let's say you want to include leaf map here, you can do that. You can just add the dependency given a specific version name here in the library and go ahead and add that. I have a bunch set up that I've used before, so you can test any of these and get started, and you can just add that dependency in. If you don't need one, you can just go to default, and then you can go ahead and start just a plain notebook server here. So that's one way to do that. So you can go ahead and start that. You'll see it'll kick off my notebook service here, and you'll see that it's running, or I can choose to shut that down at any point here. We also have some example notebooks, which are basically one-click launch notebooks, and I'll show you a few of those to get started. You mentioned one about raster, so you can actually kind of show what that looks like. I'll pull that one in here. And then we have a few different ones around cloud optimized, cloud native, geospatial formats, writing GeoParquet and stuff like that. So depending on what you want to do and accomplish, we can take a look at each of those. But before that, a few other things I wanted to point out. We also have a spatial catalog here. So I'll show you how to create your own spatial catalog if you have data in S3 already. But this is basically once you've created some tables, this is reading from Apache Iceberg, which is incredibly easy to do. These are some tables that I've created here in different places. So I have things like, I think most of my stuff is in Whereabouts here. So I have, my database, and then these are tables I've created. So this is like the city bike data set that I pulled in. You can see the entire schema here, where it's living in storage and stuff like that. And then on top of that, we have some open data here. So we have things like from Overture Maps Foundations. We have some samples from partner data. And then we have some pro examples here as well. If you're signed up to the pro account, you get access to these things as well. So there's a whole ton of data that you can work with, but it works much like a data warehouse or data catalog or anything like that from there. If you need to create a storage integration and have your data in S3, just go ahead and click on storage and click up here, enter the name, the S3 path, and then it gives you some instructions for creating an ARN role in AWS. So you can do that here. And once you've done that, it'll actually create a catalog that will show up over here. And these are external catalogs that I've created here. So you can see some different things I've created that are on different S3 buckets than the one that's provided out of the box. If you don't have S3 set up, You can use our managed storage, which you can see here is in data, and then in customer. And then these are all, S3 data sets that I've used to upload. So you can actually do that here. If you need to upload something, you can go here. You can create ingest connections, credentials to do more, batch data upload and stuff like that. Once all of that's connected in, there's a few other steps that you can kind of start to create and do. You can go into your organization settings. This is where you can track in to looking at, like things like API keys, which we'll use a little bit later to create some maps and stuff like that. So you have API keys here. There's other settings that you can, if you have like the organization access and you're like an organization admin, you can set up, things like here around security and users and stuff like that, adding things in. So you have all these different pieces here. And then getting upgraded. If you sign up through the AWS Marketplace, you'll be automatically upgraded. So that's the easiest way to get access to the higher compute tiers is going in through AWS. So once again, if you do that, there's a few different places, but the easiest way is just go to organization settings, billing, and then clicking into subscribe with AWS Marketplace. So I'll just pause there to see if there's any questions, and otherwise we can go get back into the notebooks and actually start running some different queries. Just make sure no one raised their hand. Drop any questions in the chat that you might have, anything that you want me to go back over, anything like that. I have the chat bot open, so I'm kind of scanning back and forth to make sure I'm checking the chat here as we go along. Okay, so that's kind of the overview. Once again, I said, make sure you're managing these notebooks as you're starting to spin them up. These are it's kind of the manual start and stop services. So you'll see here it will expire in 7 hours. That's kind of the default burn down time is 8 hours. It will start and stop on that time. This notebooks, there's really three service areas we have in Wherobots. Notebooks is really good for exploratory work, building your code, writing, developing, stuff like that. And then we have jobs and our spatial SQL API that are more for production workloads that allow you to do some different things there. So for the first one, let's go ahead and look at reading spatial data. There's a few different notebooks here I want to kind of go through, but we'll go ahead and start since there was a specific question about raster data. We'll go ahead and take a look at this and start with this one. So once I've started my notebook, the first thing I have to do is connect my notebook to my runtime that I've set up here. And you'll see here that I'm creating a Sedona context, which is connecting to basically the compute instance and matching the notebook to that. So what we're going to do here is load a few different data sets in. What we'll read through here is looking through some of the different files and see what the data is in this bucket. So I've created some example data sets that we can go through and use here. Just a quick poll, how many folks if you just want to add into the chat, how many people are using AWS already? Or if you're not using AWS, if you're using a different cloud provider, just drop that into the webinar chat. So let me just drop out a few of these notebooks here and get myself cleaned up because I was doing some work earlier. It looks like I have someone using Azure. And we have some support for Azure Blob Storage, so you can actually read in if it's not just from S3, other storage services as well. So now that that's connecting, okay, AWS. Yeah, everything, if you're on AWS, it's pretty easy to get set up. You can just start kind of connecting. If you have your S3 buckets, you can read things in right away. So it's very easy to do. So what I'm doing now is just connecting my notebook to the run context. Matthew, to answer your question, yeah, we provide some kind of like services to help develop and build things, either be applications, kind of getting started, whatever you need there. So there's certainly some different ways that we do that. So now that my runtime is connected, what I can do here is I can take a look at the different files that are in this bucket. So that's going to go through. You see here I have a few different things. I have two files primarily. There's a geotiff here. And then there is a NYC Buildings GeoParquet. So those are two different data sets that we'll use. What I'm going to do here is I'm going to first load in my vector data. And you can see here I'm creating a vector data frame to load that in. And that's going to go ahead and process that. I can see the data. And then I'm going to also load in a GeoJSON data frame here so you can see what's there. I have to do some processing. So it's pretty simple just to restructure the GeoJSON here. So I can do that basically since GeoJSON's a weird nested format. There's some specific things you have to do there. And then if you also have some CSV data, you can load that in here. You can do that and turn in the latitude and longitude to a proper geometry, which is what's happening in this row here. So those are the first pieces. Now, I know we mentioned some different things about raster data. Raster data is actually one of the things we work really well with. So I'll just pop over to Docs and talk about the raster loader. The most important thing to remember here is that if I go to here, we're actually loading these in as external files. So we're not pulling these to what we call in database or in memory rasters. We're actually leaving the rasters sit where they are. So we can actually connect to those from an external storage service. And I'm creating a map out to them from external data here. So that's what's happening here. I'm creating a map out to this external raster file. And then I can actually do some spatial SQL to extract some values from that raster data set. So this is actually from some external data. This is a full data set of, I think this is annual land cover change. And you can see here that this returns that value of 5. So what that looks like in a really big practice is doing some like large scale raster joins and stuff like that. We can handle that very efficiently. This is like the very simple, just connecting in data and stuff like that. So very simple way to kind of go from that perspective. Um, there's a few other things that I would also want to point out. So there's some example notebooks here under this examples folder. And what I recommend doing to kind of show like how we go from, simple just reading in data and exploring stuff into like more robust production use cases to actually build some stuff with Wherobots. That's like the next steps we'll go through here. But I wanted to pause. I know David had a question here. So talking about who's the typical user of a Wherobots and how's that compared to like, an Esri or a Google or stuff like that. So typical user of Wherobots is someone who needs to manage, spatial data at scale. And scale can be a number of different things. But if you're doing large scale batch processing, if you are developing and reading across many, very large data sets from that side and querying that, if you're connecting to large, raster data sets that are on things like AWS and you don't want to, move that data around because it can be very, time consuming and costly. That's what Wherobots does effectively. The key here is that we separate our compute from our storage. You can see all of the data, and most importantly, these examples here are stored on S3. That data never leaves S3. We're reading it directly from there and reading it in, and then performing the calculations on these data frames in memory. So these are only in memory. Again, that's an important part to call out, at least for this notebook, but it allows us to do these calculations very effectively. Let's go to a little bit more of a robust example here. So let me go into analyzing data. And what I want to do is this zonal stats analysis. And then I'm going to do one more to show us how to create tables and use some tables at scale and go from there. But this is a common use case, that we started to kind of investigate. We've seen, different users who use, Google Earth Engine or things like that to perform things like zonal statistics. And if you're not familiar with that, it's basically a join between raster and vector data. So in this case, you might want to look at elevation across a property or a building or a footprint like that. I've used that for like, flood analytics and those different things. So there's, some different ways you can do that, but this effectively allows you to do that scale. I'm actually going to start up another instance here and start up maybe at a medium scale here, just so we get a little bit more compute power. So let's do that and we can run that notebook there. But I'll talk about what's going to happen and all the different things there. And then as a final step, before we turn it over to questions and things like that, I want to, kind of open it up so you can hear some of the challenges that you're having. So it's not just a one-way conversation here. We can talk a little bit more and then go from there. So what's happening in this notebook as I spin up this other instance here, and like I said, you can just, if I'm done with these, you can go ahead and shut those down at any time. What you can see here is that I am basically connecting in my instance, and then I'm reading from this data set here, which is the ESA world cover data set. So ESA world cover, it's a data set that is open on AWS, and it's just at this endpoint here. So it's a global data set, I think 10-meter resolution. It's quite a bit of data. It's not like a small amount of data, but you can actually see what it looks like here. World cover, there's like a whole map you can actually use to see this here. And we can explore that data set here. So this is by the European Space Agency. and we can map through and see all the different data here. So this is, I'm using world cover vision 2 once that decides to load. And you'll see here, it tells me all these different things about the land cover here. So there's trees, shrublands, built up areas. You can see our urban areas start to pop up. South Florida is probably the most interesting because you have dense urban areas, you have what they call grassland, then you have, the herbaceous wetlands, things like mangroves, even in here, as you start to see some of these different areas. And then you can understand kind of the built environment from this. But it's very granular data. If we zoom in, you can kind of see here, I think there's like an opacity reading here somewhere, maybe. Um, Oops, that didn't do what I wanted to do. Um, yeah, well, you can kind of get the idea is that there's very granular data here as you zoom in. You can see how specific it is to these different areas, but it gives us a lot of data to work with. Now, the problem is this is many gigabytes of data, like hundreds of gigabytes of data. I don't want to have to move this back and forth, right? Google Earth Engine allows you to access that, but you have to use their APIs and things like that. And it's not very scalable from that perspective. So what our system allows you to do is basically connect to a remote data frame here. And we're actually going to be able to read that in. So Vignesh, yeah, that's kind of, we can use world scale compute and actually do it more efficiently compared to Earth Engine or something like that. And that's effectively the scale that we're trying to reach. So we have basically, we're connecting to this. It's a spatiotemporal asset catalog. I can load that in and then see that as a data point. So anything effectively that's on AWS Open Data that has a stack endpoint, you can read it there, or you can just read it in directly from S3 here, and you can load it in, and then you're creating what we call an out of database raster, right? And what is happening here is we're actually creating a table reference to that. So if you see here, if you're replacing this with your org catalog, your database name, stuff like that. If I go back to my, let's go ahead and actually get this started here. Uh, I can get this notebook going here so we have things running. You'll see on my spatial catalog, Wherobots, and then I should have ESA here. I have a remote table reference to that data. So now I've stored that basically as tiles, but I'm not storing any actual data. I'm storing a reference to the correct tile on S3 that AWS is hosting for me. So I'm just creating a reference to that. And that allows me to do things like spatial joins, zonal stats, all these different things very efficiently. And what's really, I guess, unique about Wherobots is that specifically with raster processing, we can only process the pixels we need at runtime. So when the query runs, we'll process just those pixels we need, nothing more, nothing less. And it's very, very efficient to that for, kind of really large scale processing. So once that runs, we'll create those different tables, and then we'll actually kind of create a bounding box to see how we can do this, for basically for every building in the Overture Maps data set. So I'm pulling that in. Again, this is from that open data we have. I'm selecting the buildings. I'm creating just a 30-meter buffer around the building so we see not just the land cover in the building, but just slightly around it. I'm doing some basic repartitioning and stuff like that here. And then I'm loading that in to this view Texas buildings. And then this is the zonal stats computation. So it'll actually go ahead and run this, and then I can actually save that as a table, which is what we'll do. And then we'll put that in a map to wrap the whole thing up here at the end of this. So once that is connected, we'll create that, and then I'll show you how you can actually pull that into a map using a tool called Descartes, which is much like Kepler-GL, but allows you to connect into data backends. So once this runtime gets connected here, I'm going to go ahead and once again, important step here, just clean up the notebooks as you go along. I'm just going to keep the medium running since I don't need these now. I'll shut them down. So once they're shut down, that'll kill the clock on whatever is running, and then you're ready to go. And then we'll get this running, and then I'll just show that Descartes integration here as we get it set up. So to set up the Descartes integration, this is a new feature. Descartes has a free platform that you can actually start with. So I think if I'm should be logged in. There's different tiers if you wanted to go to like a larger tier. They have options for that as well, but there's a free kind of service that you can create here. There's different connections. So I've created a connection to my Wherobots account. All I have to do that is go ahead and collect that API key. So again, that's in uh, community settings, API keys, and then create new key. and then you'll be able to copy that key value and just put that in here. You can select the default runtime it runs on. So if you have, just if you want to use just the tiny runtime or you want to use a different one to query that a little bit faster, you can. And then you can start to build maps from that. But we'll get back to that in a minute once this sets up. So here, just to demonstrate everything, I'm connecting to that remote data set. You can see here I have all the attributes from that spatiotemporal asset catalog. Most importantly, the links to the actual raster grids, and I can see what those look like there. Otherwise, I can just manually connect to those over S3 and then create a data frame here. So I'm creating this data frame. I'm just going to change this so it's Wherobots and then ESA mat, call it there. You'll see what the data structure looks like here. So you'll see there's like an X and a Y. There's like basically a tile grid mapping much to the tile grid in the cloud optimized GeoTIFF. So if I went to ESA, let's just go here, ESA world cover on AWS. There's only a stack endpoint, so you can kind of see this is the endpoint here that it provides. And then there's some viewers where you can actually view and go through this data as well. But here's the data structure. As you see, it's out DB coverage, so it's creating a map to that tile that's 256 by 256 pixels, basically. I can create that as a table. So we'll go ahead and do that here, create my new database. And then now I've just basically created this remote reference to this table. So now I have all of that stored. I haven't moved any data around. Let's just see here. Oh, org catalog. That would be the problem there. And then now I have this as that remote reference. So again, we can run this entire process. We'll just run it for this small bounding box in Dallas, just for speed purposes. What I'm going to do here is, once that gets created, I'll go ahead and this is the whole global data set, by the way. So we're referencing everything in the globe, so I can move that around and capture that anytime. But any of those data sets that live in AWS, like open data, this is some of the data you can see here. Explore geospatial data sets. There's lots of stuff here. Landsat, anything here that you can pull in. So it's very easy to do that. You can do the same stuff with vector data as well. So once that's finished, we can then run our bounding box here. So this is just a small area around Dallas. And then if you just want to see, I think there's like a WKT viewer. Let's just try that. So you can see here's the area that we're looking at around Dallas. So we're just going to be pulling all of the buildings from Overture Maps that fall into that area. And then what we'll do is basically add that small buffer and then basically figure out how many buildings we have here from that side. So that's all doing the processing here. Looks like there's 758,000 buildings in this area. And then I'm just going to, again, create this as a table that is going to be there. So because I've created this, I now have that stored as a table. This isn't in memory. It's not like a PostGIS database. It's actually Iceberg is nice because it just stores it as GeoParquet files, and that's all you're storing here. So you're only creating data on your S3 bucket. So it's very, very cost effective. We have connections into Google Cloud Storage as well as into Azure storage as well. So if you need help getting that set up, just don't hesitate to reach out. We can follow up with you and connect there. And then here I'm just going to run the actual zonal stats. So I'm actually going to create this as a table so I can see that later. So create a replace table. Here's Wherobots, my data name, Texas buildings. We'll call it, here we go, join. And then what I'm doing here is just running this zonal stats function. So just get me all of the zonal stats in that area. So it's getting me like the min, max, mean, all those different things across those things. Let me see what I did wrong here. Of course, or catalog. Your database name. Create replace table as, there we go. Nope. Table or view. Let's see what happened here. There. That would be the problem. So here we go. We'll go ahead and run this. It should take a handful of seconds here. So again, we're doing this for all 758,000 buildings across that area with the 30-meter buffer and all on remote data. So it's only going to ever pull in the pixels it needs to do the calculation. Nothing more, nothing less. Have not moved any raster data. the data's still on that AWS bucket somewhere. And then it's just going to run the calculation here. So usually this only takes a handful of seconds. And then once that's done, we can actually pull this in as a map. So once we have that complete, I'm going to get a smaller bounding box just to grab a smaller area here. But then we can create the map over into cart and go from there. So let's see how long this took. This should take, yep, that's done now. So that our join is done. And let's go ahead and create a new map here. So I'm going to run a query from Wherobots, and this is using that spatial SQL API in the backend. You can kind of use anything you want. So I think I called my database. Let's go back to my notebook here. And I can shut this down. And now that I'm basically done with the processing, that data is now stored in that table. So I'm done with this notebook. I can go ahead and destroy that. I don't need to keep it running for no purpose. So we'll just go ahead and destroy it. Well, I can destroy it. I'll leave it. Maybe I have to go back. So I'll just leave it open for now if we need to do anything else while we're talking here today. So we'll go select star from, and let's just get a very small bounding box here. Go to Dallas. Oh, that's not in Dallas, Texas. And I'm just going to pick a really small area so we can just read the data really quickly. Let's go here. I think this is within that area we mentioned. Let's keep it really focused here. Pull in as WKT. And then you will see me do some live coding here. Select star from there, where ST intersects geometry, and then ST um, text. And let me make sure I ran this all correctly. I'll get an error if I didn't. So I'm running that query. It's going out to that remote table. Again, that table lives in just your S3 storage in Iceberg. You can see that if you really want to dig into it, now you'll see that I have Wherobots, ESA mat. Here's where that's living, and that's the storage table there. This is just going to run and spin up that. It's spinning up a separate instance, so it's using just a smaller instance. I'm only querying data over the wire here. I don't need to do anything more advanced than that. So I'm just going to use a smaller instance, and then that will pull that data onto the map, and I can start to visualize that, take a look at that. So that's kind of the full spectrum of like A to Z, finding your data, connecting it in, loading it, moving into the catalog service as Iceberg tables, doing your processing. You can easily convert that notebook into a job and start running it as a regular sync if you need to do that on a regular basis. So and then, querying that into different applications, which is what we're doing under the hood here. So as that starts to load, basically what it's doing is it's doing that spinning up of the runtime. It'll keep that hot for a minute, and then basically it'll shut down after that, so you're not consuming extra compute from that side. So once that's spun up, I should get the results here and go from there. But I wanted to pause as that map is going and see what other questions there were. You can either put them into the chat, or if you want to raise your hand, I can answer those live. Okay, so yeah, one question here. I'm just going to unmute you, and then yeah, you can go ahead and ask question.
Hey Matt. So I have one question. Is it really necessary to connect a storage account with Wherobots?
Mukesh,
Like,
I think you
can
can if you're unmuted, I think you can ask the question.
hello?
Can you hear
Can
me
you
all right?
hear me? Can you hear me? Hello? Um, hello?
Oh, why can I not hear it? That's a good question. Let me see if there's something wrong with my Zoom audio. Let's try that. Can you try it again?
Yeah. Can you
I
hear me now?
There we go. Okay, that's my
Perfect.
fault. All right.
That's okay.
Try
So
something.
Matt, I have Yeah, I have one question, and the question is, so is it really necessary to connect a blob storage to Wherobots? Like, if I, let's say, if I want to create my own lake houses within Wherobots, which are managed by Wherobots, can I do that? Like, if I don't want to use Amazon Web Services or Azure for my blob storage, like the storage account, I just want to create my lake houses within Wherobots. Is that possible?
Yeah, so we like I said, we have a storage integration like out of the box. So here's your storage here. You can go ahead and upload data to this, which is our managed storage. You see my other ones I've connected here. Um, and
But
then
like, can I write to it from the notebook itself?
yes, you can. So what's happening there is you kind of like I think there's one part where I kind of have you can find the this code to find the user S3 path, which is where the
Mm-hmm.
environment variable is stored. That'll get you that user path. Or if you just want to manually copy it, you can kind of see here's the path that it's providing there. So that's
Okay.
so you can use ours to do that as well. Yeah.
So basically, if I want to create a medallion architecture within Whereabouts, that's possible, right?
Hmm.
I don't have to leave the environment at all.
No, exactly. Yeah, you don't have to.
Okay, perfect. And one more thing. So, is there any IDE integration with Whereabouts? Like, if I want to develop in Visual Studio Code instead of this web browser kind of a layout, is that possible?
Not right now, but that's something we're working on is actually allowing you to kind of connect to a remote runtime and like VS Code or whatever you want to use. Yeah.
All right. Okay.
Yeah. So right now, you can develop, all the code here. If you're using like Sedona on your own setup, you can also, go ahead and write your Sedona code, then hoist that into Wherobots here. But yeah.
Mm, okay. Perfect. And it's just the iceberg that are supported right now, no delta tables.
More news to come on Delta soon. So if right now we support Delta Lake here, so you can read Delta. There's some different
Hmm.
steps here, and then we're literally like we'll make sure we send it to you, but we're going to support writing Delta um, in days, so it's coming out very soon.
All right. Perfect.
Yep,
Thank you.
yep. So a lot more to come there. Do you use Databricks? Is that kind of your main environment right now that you're using, or kind of what do you use
Yeah.
to? Okay.
So I am using Databricks and also I'm doing a small POC using Microsoft Fabric. So both the things.
Yep. Okay. Got it. Yeah. Yeah, I think, the biggest differences you'll see um are, really the ability to, the processing speed on doing some of those different things here. Maybe I wrote my query wrong in the map here. That one's taking too long. Yeah, I had a wrong column there. So I'll go back and check that in a sec. But effectively, um, the most important part here is like this compute will probably take 30 seconds where it will take many minutes on other systems. So that saves in terms of compute cost. And then the other really unique thing when you're dealing with raster data is the out of database connection. Like Sedona on its core, you have to kind of move data like raster into in-memory data. Like we're just creating a reference here, so we never have to move that data at all. So that's a huge advantage to be able to do that.
Yeah, but sorry, Matt, but I can do that in any environment, right? Because this out database feature is not just for whereabouts. It's like I can do it wherever I use Sedona, right? Or it's just, or is
That's
it
that
something?
yeah, that's specific to Wherobots. So like yeah, Sedona
Okay.
is extra stuff generally has to be like in memory because of all the pixels, but this is
Yeah.
unique to Wherobots. Yeah.
Okay. Perfect.
Yeah. It's the combination of like the Wherobots plus Iceberg plus the processing. So all those pieces, but yes.
Okay.
Great. Any other questions from the group here? If you wanted to raise your hand, do that or drop that into the text box, you can do that here as well.
Can I ask one more question there?
Yeah, of course.
Yeah. I maybe you'll go there, but I did not see any scheduling kind of a option in this platform. Is it somewhere else, or we will have to use Airflow for running these notebooks?
To run the jobs, there's two, yeah, so recurrent jobs, kind of the same question from Vinesh here. There's two different ways to do that. So if you go to workload management, there's a jobs REST API. So effectively, you can convert your notebook into Python and then host that Python code in Wherobots or just any S3 service. And then you can run this as a job here. So you can pick the runtime, you build this as an API into the service you want. It'll run Python. You'll give it a path to that Python file that you're storing, and then that can run it there. There's also, if I go back here, there's a Whereabouts Airflow provider, so you can actually do the exact same thing, but just it's the same effective like setup. You need the runtime, the Python file hosted, all of that, and then you can do that with Airflow here. So you can actually connect that, store your API key, and do all the different pieces there.
All right. So basically, if I'm using Wherobots, so Wherobots can be used as a transformation platform, but then
Yeah.
orchestration has to happen through Airflow.
Yeah, the orchestration is right now through Airflow or through,
Yeah.
whatever you build with the REST API.
Okay. Got you.
Yeah, it's a pretty common one we get. And we're kind of adding some different pieces for job management. So you can do, some, either scheduling or stuff like that. But a lot of customers are using Airflow as well. So, if you have that up and running, you can do that and then kind of handle any of the other pieces that Airflow does really well. Or just do that directly with the REST API. You can process those things there.
Yeah. Um, and what about Git integration?
Pardon?
Git integration, like if I'm for the version control, so I can keep changing my notebook, but is there any version control option there so that I can, do kind of like dev test and production and don't mess up with my production notebooks?
There's not in terms of like how the notebooks are kind of stored, so there's no pieces there. But
Mhm.
you could kind of store your notebooks independently and handle them from that side. But yeah, if that's something you're interested in, we'd love to dive into that more and learn a little bit more about it.
Okay, thank you.
Yep. Yeah, Vinesh, did I answer your question on the recurrent jobs? Was that kind of the question you had there? And if okay, perfect. Great. Any other questions from the group here? And I'm realizing what I did wrong here. I was running this, so I'm glad I didn't shut this down midstream. Was I forgot to include the geometry there, which is what this was looking for. So I can go ahead and run that and see if we can get a map here at the end of this and just allow any more time for any other questions. While that's running, I just wanted to quickly talk a little bit about other ways to, kind of go ahead and get started. If you're interested in trying things out, once again, if you want to sign up, the fastest and easiest way to do that is to go through the uh, AWS Marketplace, why am I having such a fun? Let's go here, settings. Is it organization settings? Yep, here we go. You can go into AWS Marketplace. You can go ahead and deploy this. It'll deploy natively on your AWS instance and get started there. That's probably the quickest and easiest way to get up and running and testing out all the features that we have from that perspective. And yeah, those are kind of the core pieces from today. And just kind of to get you acclimated there. The folks on our team will follow up with you to ask any specific questions from today. Make sure you have what you need to go ahead and get started. If there's anything else that pops up, you can proactively reach out to us as well. And then, yeah, we'll follow up to make sure that we can provide you the support that you need from that perspective. But if there's no more questions, we can leave it there for today and, kind of check in next time. But hopefully that was helpful to get you kind of an overview of where we're at with the platform and what we're doing. And yeah, we will take it from there. So thank you everyone for taking the time to attend. And we will be in touch. And yeah, let us know if there's questions that pop up. And we're looking forward to getting you started on Whereabouts. All right. Thanks, everyone.